Hello there.
Hi there.
How are you? Hello, Tumelo.
Hi, Tumelo. Welcome, Ayanda.
VN Cube, what do we call you?
Oh, I can't really hear you, but I'm having trouble fixing my username.
Your username. Let me see if I fix it for you.
I'm having trouble fixing my username, but I can't hear you, so I don't really understand what I
What's your
can do.
name? Can you hear me?
Oh, I can't really hear you, so may you please type in the chat?
Of course. So let me just send a message to him.
He might have to leave and come back so that he can fix his microphone.
Yeah, that's a good idea.
Oh, I can hear you now, sorry.
Can you hear us?
Okay. Can you hear us? Good
Yeah.
stuff.
What's your name?
My name is Owami, but I can't.
Owami.
It's difficult for me to choose mine.
Owami.
Owami, no worries. I'm gonna change your name.
Okay, thank you.
Hello, Kumano and Ayanda.
Hi, Kamanu. Ayanda and Tumelo. Okay, so those of you who are here, there's an exercise up on the board. It's a do now. So that's what you need to do right now is start on these questions. What I want you to do is look at the pattern and then write in how many number of red squares will be in the 5th, 6th, and 7th pattern and how many black squares. So while we wait for everyone, I want you to just keep busy doing that right now. Barclay, welcome. And Pumuzile is here as well. Welcome, Pumuzile. Please start with the do now activity that's on the board. Look at the pattern and then write down how many red squares, black squares there are in the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th picture. Trevor, welcome back. Diwa, you are back as well. Welcome. Aisha, welcome back. Good to see you. And Punolo.
Ma'am, I'm not shy.
Can you repeat that again?
I'm saying I'm not shy.
You're not shy.
Yes.
That's good. Cananello, welcome. Tamisho. Great stuff. Everyone who's here, start with the do now that's on the board, please.
So guys, while you are busy with what Marlies just asked to do on the board, I also just want to remind you that when you're not talking or when you're not asking any questions, to just please unmute or mute yourself. And as soon as you have a question, you can unmute yourself again. And then if you want to ask anything as well, you can also just type it in the chat. And we'd love to see some emojis in the chat as well, okay? So feel free to share some emojis on how you're feeling tonight.
How do you feel, Elzon? I'm going to put a smiley face. I feel pretty good today.
I feel very good today as well. Very happy to see everyone attend again.
Great. That's great, Bonolo. Happy that you're feeling good today too. Welcome, Anel. I see you here again today as well. Wonderful.
Hi, Ayesha and Ayanda. It looks like an excited face. Then I also want to remind you guys that there are two types of emojis. So you either have your reactions or you have the emojis that you can put on the chat. And we'd love to see you share the emojis that you can put on the chat, okay? Then Marlies will be able to see them as well. Cananelo, feeling very good.
Cananelo.
82%. We all
That's
give
amazing.
Cananelo.
Well done. That's excellent.
What is goody teacher? Who's asking that question?
Just says iPhone. Hi, Theo.
Hi, ma'am.
Okay, make sure you're busy with your do now. We're going to give it 1 more minute and then we're going to start going through the answers. Zon, maybe we can get iPhone to just change their name.
Yes. I am sending him a message now. So just to remind all of you again, if you don't have your own name on, please rename it to your own name so that Marlies and I can just know who we're talking with if you have a question. And when it's like iPhone or Galaxy A30 especially, we'd love to see your names. So just change that, please. Thank you.
That's okay. We are still busy, so we're just busy with our do now. So if you're a little bit late, just do what you can before we start going through. Stimbiso, welcome to you as well. Hi, everyone. It's great to see you.
Mm-hmm.
Right, 1 more minute, and then we're going to look at our answers for this pattern. If you're done already filling in how many red squares and black squares there are in the pattern, then please go on and write a rule for the number of red squares. This is just some revision of what we did on Tuesday. Okay, let's have a look. If you're not done, don't stress. You can just follow as we go through. Those who have done the question that's on the board, let's have a look. The number of red squares in the first picture, I think we can all agree that there are 6 red squares and 3 black ones. In the second one, there are 10 red squares and 6 black ones. Who wants to give me the number of red squares and black squares in the third picture? Barclay, you have your hand up. Please unmute yourself and then you can just give me the answer.
14, ma'am.
14 and black squares, 11.
Yes.
Excellent. Trevor, you have your hand up. Give us the fourth one. Would you agree? Is it 18 and 18, Trevor? Just unmute yourself if you need to answer. Okay. Njabulo, give us the fifth picture.
Ma'am, it's 22 red squares and 27 black squares.
Awesome. And for the sixth one, I get 26 and 38. And for the seventh one, 30 and 51. Great. Now, who can give me the rule for the number of red squares?
You add plus 4, ma'am.
Say that again.
You add plus 4.
Okay, so that's one way of putting it. We say that we can add 4 each time, and we can see that in the pattern, right? So if I go like that, I add 4, and again 4, and 4, and 4, and so on. Okay, so who can tell me? That's one way of saying it. Can anyone make a rule like we did on Monday with using the number, the figure number, the arrangement number, and the number of red squares? What is the rule if we write it with numbers, and what we did last time was with an n, with a variable? Can anyone give it a go? Cananello, you have your hand up. Do you want to try? Just unmute yourself.
Is it 2n plus 1?
Okay, 2n plus 1. Let's try it. 2n plus 1. So the n has to be the arrangement number, right? So let's see if it works. So if I just try and work out the first picture, 2 and 1 plus 1, that gives me 3, okay? So I need to get 6. So that's not quite the correct one. Does anyone else have other ideas?
It's gonna be 36.
Who's got an idea for the rule? Just mute yourself, please, if you're not speaking. Who wants to give me the rule with the n? Did we forget already from Monday?
I see a hand from Cananello or from Barclay.
Cananello, do you want to try again? Just unmute yourself.
I'm still busy working it out. So you
Okay.
can give another person.
Okay,
Ayanta?
Barclay, do you want to try? Barclay, your hand is up, so you can give us the answer.
N plus 1.
N plus 1. So if we take the arrangements, the number, the first picture, this one here, and I add 1, will I get 6? No, I don't think that's going to work. Let's see. Trevor typed an answer here in the chat. Trevor said it's 4n plus 2. 4n plus 2. Let's see if that works. So if I want to check if the rule works, then I can do it for the first picture, where the n is 1 plus 2. That's 6. Okay, that works. I get the same. Does it work for the second picture? So what will n be in the second picture? You can tell me. Just shout it out. What will n be for the second picture? Can you guys hear me? What is N for the second picture? 2. Okay, so some people are typing. Aisha, thank you. I see Anel also did. So that's 2. So 4 times 2 plus 2. 4 times 2 gives me 8, plus 2 is 10. Okay, yes, it works. I think that is the right answer. The rule for the number of red squares. Each time I have to take the arrangement number, times it by that's my N, I times it by 4, and I add 2. How do I know? Okay, so for those of you who struggled, maybe didn't get it right, how can I tell what I need to multiply N by? And here's my clue, listen carefully. We said that each time we have to add 4, and we add 4, and we add 4, and we add 4. And then we said the rule is 4n plus 2. So what do I multiply my n by each time? What do you see that's the same each time? I add 4 and I multiply by 4. So what is the relationship? How do we then know what we must multiply n by? Who can tell me? Ayanda, you have your hand up. Just unmute yourself and let me know. What do you think?
Ma'am, I'm still trying to work it out.
Okay, but just listen to the question. If I'm making these rules, right? How do I know when I make the rule what I must multiply by each time? Has anyone spotted it? Has anyone noticed? In this pattern, we added 4 each time, and then we multiplied n by 4. So what do I do each time? Trevor, let's hear.
Okay. So, ma'am, the question that you were saying, do we have to multiply each one by 4? Like if you say 4 times by n.
Yes. So each time, this number that we keep adding is the same as what we multiply n by to make the rule for our pattern. Okay. So let's maybe think about this. Okay. So we'll get back to that, but that's important for those of you who maybe struggle to make the rule. What you add when you do the pattern and you add the 4, that is the same as what you multiply your n by each time. Okay. So let's keep that in mind as we carry on working. Now, let's read the next question. It says, Natasha decided to use the formula y is 4 times x plus 2 to calculate the number of red squares in the arrangement. Okay. So she said y is 4 times x plus 2. Who can tell me what you think the x and the y represents? So we're still working with the same pattern, still working with the red squares. What do you think the y and the x stands for? Yes, Trevor.
Okay, so the y, it means the output number, and also the x, it means the input number.
Okay, great. Now for everyone who might not know what an output and an input number is, look at our picture and just explain what the y stands for and the x stands for using our pattern here. So if I had to say x, which in our pattern, what is x? Barclay, do you want to try?
X is 1, 2, 3, 4, 5, 6, and 7. And y is the answers 6, 10, 14, 18, 22, 26, 30.
Lovely. Okay. So x is, in other words, the variable. Instead of writing arrangement number, we just say it's x. Okay, it's shorter, it's quicker, it's easier. And instead of saying number of red squares, we just write a y. Okay, so the y stands for the red squares, and the x stands for the arrangement number. Too long to write all of that. I don't have time. We mathematicians, we're always in a hurry. Okay,
Yeah.
so we choose letters. Does it matter whether I choose an X, an A, B, a C, an N? Does it matter? I want to hear from someone else. Wami, what do you think? Do you think it matters if you choose a different letter than an X and a Y?
I was told it doesn't matter.
That's it. It doesn't matter as long as you say what the letter represents. So it's quite nice. Say we can choose our own letters in algebra as long as we say what the letters stand for. Okay, Cananello, you have your hand up. Do you want to ask a question?
No, ma'am. I just wanted to answer the previous question, but never mind.
Okay, so you're good with doesn't matter about which variables to use. Okay, I'm just going to pause for a second because I see there's loads of messages in the chat. Okay, as people say no, no, no. Okay, input and output. Okay, I'm really glad if you know what input and output is, but we also have to make sure that for our specific situation, what is the input and what is the output? So for our specific situation with this pattern, the arrangement number is going to be the input, and the number of squares is going to be the output. Okay. Now I want you to use that formula. We're going to answer question C. Use the formula to calculate the number of red squares in arrangements 20, 21, and 22. If you're not sure what to do, please ask, either in the chat or just unmute yourself and talk to me. Okay, just read the message from Alzan about changing your name to your real name, please, so that we know who we're talking to, so that we can take the register as well and know who you are. Njabulo, for now, I just want you to work it out on your own, and we're gonna, in another minute, we are going to go through the answer, and then you are welcome to put your hand up and give an answer. Okay.
Ma'am?
Yes.
I'm actually not sure how to do this.
Okay. Okay, let's see, Cananello. So if we want to work out the number of red squares in arrangement 20, 21, and 22, and we have to use that rule, the rule that we've been working with, okay? We're going to say, so what does X represent? What does Y represent? So X is the input number. In other words, the arrangement number. So if I go first picture, second picture, third picture, and so on. So that's what X is. So for the first one, X is 20. So for the first one we're answering, X is 20. So we'll say Y is equal to 4 times 20 plus 2.
Oh, okay. Thank you, ma'am.
Got it. Okay.
Yes.
So
Thank you.
4 times 20, I think that's 80. You must check my thinking, eh? You must check if I do this right. 4 times 20 is 80, 82.
Yes.
Phew, got that. So in the next one, what is x going to be?
X is going to be 21.
Mm-hmm. And in the last one?
X is going to be 22.
Good stuff. Okay, so Jethro, Katie, Aisha. Okay, so you guys say, okay, so you didn't hear me properly. All right. So can you guys just tell me, I did now explain since you posted your message. So I just want to know if you're okay now. Jethro and Katie. Katie's asking at our help. Okay, so here's our numbers for x. So x is 20 in the first question. In the second question, x is 21. And then x is 22. So we keep putting it into our rule because the number for x changes. It tells us that x is 20, 21, and 22. Let me know if you're okay now. Okay, Aisha, great. I'm glad you're with us.
It's all good, ma'am.
Wonderful. Okay, so Mapolo, you tell us that this next one is 86. Okay, great. Everyone seems to understand. Okay, so Sitin Biso is asking, how does pattern and sequence help with algebra? I'm going to answer that question right now. So 4 times 22, let's just do this last one. Jethro, do you want to give me an answer?
Ma'am?
Yeah, 4 times 22.
Ma'am, it's
Plus
176, ma'am.
176. I think we must think again. We say 4 times 22.
22.
Okay, so
it's 88.
let's help. Okay, I see you guys, Mapolo, everyone, you guys are giving 90. That's right.
Okay, 90.
Okay, so
It's 80.
I just want to see where that question went about how does this help. Sitimbiso, algebra is all about patterns and sequences. And I want you to just hang tight till the end of this lesson, okay? Because I think you're gonna see why it's all like this. Okay, so just work with us and then you're gonna see it's gonna all come together. What we are doing already is algebra, okay? Right, let's carry on. And we're gonna do some more working with rules and filling in some tables. Okay, so in this first table, it says multiply n by 4 and add 5. Multiply n by 4 and add 5. So where's my n? N is here in the top row, right? So n is 1, n is 2, n is 3, n is 4, n is 5, etc. Okay. Then what is that you can think of as your input. Then Tn, we just give it another variable name. It's not important what it is, it's just Tn. But that output number is what I want you now to work out here. And here, and here, and here. And then if you work fast, you can go on to question 2 as well. Now it says multiply n by 4. I'm going to do the first one. If you're a little bit stuck, multiply n by 4. So n is 3, so I must multiply that by 4 and add 5. So 3 times 4 is 12, plus 5, 17. Okay. Don't put your answers in the chat just yet. I just want everyone to get a chance to think first. Okay, so just hold off a little bit on your answers.
Yes, ma'am.
Thank you. Okay, if you haven't answered yet, get ready, because I want everyone to get a turn to share their thinking. Yeah, keep trying. And if you are stuck, don't be scared. You see people asking questions, just ask a question. We're going to give it just 30 more seconds. Right, let's hear it. Kimono, you had your hand up first. I want you to give me the first table, those 3 answers for the first table, please. Go right ahead.
Yes, ma'am. For 4, it's 21. It's 21.
Yep.
And then for 7, it's 33.
Yep.
And then for 10, it's 49.
Let's think again. We multiply n, which is 10, by 4 and add 5. So that gives me 45. Okay, so this one's 45. And then the previous one was 7 times 4 5 is 32, I think. Yeah, 7 times 4 is 28 plus 5 is 32. Okay, let's just fix that one. Thank you, Kimono. Let me see. 21, 45. Okay, 45. There we go. Right. Pumzile, I wonder if you want to give us the next one. Pumzile, do you want to try? Okay, Pumzile, you said you are done. So you can give us the answers here for the second table. Okay, there's quite a few hands up. Okay, Pumzile, I'm going to give someone else a chance, okay? Maybe you can do the next one. Who hasn't spoken to me today yet? Tumelo? Let's hear. Tumelo, can
Yes,
you hear
ma'am.
me? Okay,
Yes.
fire away.
It's 60.
16, I agree with that. Nice. Next one.
$23.
23, I also agree with that. And then the next one.
30.
Okay, let's do the next one together. N is 7, and I multiply that by 7, and then subtract 5. What do I get? 7 times
Excuse
7 is 49, minus 5 is 44. Yes, thanks, Mapolo. I think you got that one. Last one, Tumelo.
70.
Okay, let's do this together. Watch closely on the board, eh? So n times 7, so 10 times 7, because n is 10, minus 5. We do 10 times 7 first, right? Because of order of operations. The multiplication goes first. So that's 70 minus 5, and that is 65. Okay, great stuff. Well done, everyone. There's no volume. I'm so sorry. I'm not sure why. Can everyone else hear me? I think everyone else can hear me, Pumuzile.
Yes, ma'am.
Maybe
Yes,
just
ma'am.
just see if you can refresh, or if you can maybe leave and come back. Also,
Yes,
maybe if you
that might be a good question. Pumizile, if you can just go out and come back in again, then you can tell us if you hear us. Okay.
Okay, guys. Well done. Guys are working beautifully today. Some more patterns. This one I think we can do quickly. So we can see the diagram number. Remember now we've got the diagram number and the number of circles. So all we're doing is now we've all said, okay, that is an input and an output. Okay, so let's do this one quickly. So in the first picture, we've got 2 dots. And in the second one, there's 4. And in the third one, there's 6. And in the fourth one, there's 8. And in the fifth one, there's 10. So what would you say if you look at our pattern here? Now, listen carefully to the question. What stays the same and what changes? What stays the same and what changes? Let's think about that for a second. Njabulu, you've got your hand up. Tell me.
Ma'am, what stays the same that you're adding to? What changes is that the numbers are different when you keep on adding?
That's right. So each time we add 2, so that stays the same. The number of circles in each row, that changes. The diagram number, that changes as well. Okay, great, well done. Now, what is the rule for the pattern? And I want you to try and do that with an n. If we say the diagram number is n, what is the rule for the pattern? So Njabula told us that each time I must add 2 and 2 and 2 and so on. Okay, so what is the rule for the pattern? Write it like we did these previous ones. I'm just going to scroll up to remind you what we did here. I want you to write it like that. So I'm going to say the diagram number, let's call that N, and the number of circles per row, I'm going to call that an R. So if I had to make a rule that says the number of circles equals, and then you have to complete it. What is the rule? As soon as you're ready, you can put your hand up or type it in the chat. Kumazile, can you hear us now?
So, Marlies, I think she can hear us. I just don't think she can speak to us.
Oh, I see.
So, yeah. Kumizile, if you want to try and log out and come back in again, you're more than welcome to. Otherwise, you can just chat with us in the chat box.
Okay, guys, I see you all saying add 2. Yes, that is right. But I want you to make a rule to say the diagram number, must I times that? What must I do with the N to get the number of circles in the row? So write a rule like we did here using symbols, letters, and numbers. Let me know when you got it, and then or just type it in the chat. Barclay, you saying times n2 or n times 2? Yes, I would agree with that. So if I want the number of circles, that's the R, then I can say 2 times the n. 2 times n. That gives me the number of circles in each row. Good. Now I come back to the idea, what changes each time? What changes, we said, is the diagram number. This changes. What doesn't change is the 2. For this pattern, each time, I times by 2, I times by 2, I times by 2. So if it stays the same, we call that a constant. That doesn't change. What else changes? The number of circles. Oops. That changes. So that's why we call this 2 a constant. And the n for diagram number, that changes. We call that a variable because it changes. It can take on a 1, it can be a 2, it can be a 3, it can be a 4, it can be anything. That's why we call it a variable. It varies, it changes. Okay, I'm going to skip that flow diagram and I want you to now go do this next bit. Let me just fix the board. Okay, where it says check your understanding. I want you to do that part now. It says the rule 2 times n minus 1 can be used to determine any odd number in this sequence. So the sequence is 1, 3, 5, 7, 9, etc. 2 minutes, I want you to say what does the letter N represent? What is the constant? And then use your rule to calculate the 10th odd number. Okay, so there's our rule. Tell me, what does the n represent? Which numbers are constant? And then calculate the 10th odd number.
Ma'am, when you say that, what does the letter N represent in the rule? Does that mean like in the rule in general, or like in that question? In
this one. In this one. Yeah.
Ma'am, is 13579 input or output, ma'am?
Good question. Good question. If we had to put that in a table, would those be the outputs or would that be the inputs? What do you think?
Outputs.
Those are the outputs. Yeah. So what will be the N? N will be what? What does the N represent?
N represents
The N represents
Don't tell
one.
me yet, just work on your own. See if you can figure it out.
It represents the odd numbers.
Sorry, I'm not sure who's speaking.
It represents the odd numbers.
Okay. Who was that? Sorry, I have to look here to see who's speaking. Tumelo. Okay, Ayanda, you say you do not understand. Okay, just ask a question. You do not understand what you need to do, or do you not understand about the constant and what N represents?
Ma'am,
Yeah.
I don't understand what to do, and I don't understand what N represents.
Okay, so let's go back to the previous question here. We made this rule for the number of circles, right? So we said the number of circles 2, 4, 6, 8. And we said the rule for this pattern is 2 times n. And we said the number of circles, we're going to give that a variable. We're going to call it r. And the variable that represents the diagram number or the input number, we're going to call that n. Okay, so I said what changes, what stays the same. What changes each time is the number of circles, and what changes also each time you work out is the diagram number. But what doesn't change is the 2. The 2 each time to create the next number in the sequence, you use that 2. It stays constant. It's the same. Okay, that's why we call it a constant. Now, in this one, who can tell us what the constant is in this first one?
Ma'am?
Jabulo? Yeah?
Ma'am, the constant is 2, ma'am.
Yeah, and what else doesn't change?
-1.
The -1. That's the rule. Each time you work with this pattern, you're going to times by 2 and subtract a 1. Times by 2 and subtract a 1. Those are constants. Okay.
Yes.
What is going to change?
N.
N
The
is
N, ma'am.
changing. N is changing. And what did you guys told me the N is called a what? It's an input. So the input number keeps changing. And each time we are going to get a different output number. Okay. So what does the N represent? You could have said
Change,
N is
ma'am.
the input. So I'm going to take this pattern actually now and just draw a quick table here for it. Maybe that'll help us. Okay, so this is our odd number. And this we can say is our input. Okay, so which is the constant? It's the times by 2 is constant, and minus 1 is constant. Each time you want to work out another odd number, you're going to times by 2 and subtract a 1. Okay, now let's use that rule for the 10th odd number. So what is my input? There's our rule. It says we must times 2n. N is this. This is my odd number. 2 times n minus 1. So what is the 10th odd number? How will we calculate it using the rule? Njabulu, do you know? Trevor, yes.
Okay, ma'am. We can say 2 times 19 minus 1.
Okay, but we're working out the 10th odd number, hey?
Okay.
Please, please. Like, please.
Cananello, do you want to answer?
Yes, ma'am.
Yeah.
So we say 2 times 10 minus 1, which will
Minus
give
1.
you, yes. So 2 times 10 is 20. So you're going to say 20 minus 1 equals 19.
That's right. And that's the 10th odd number. Yeah, great. And we use the rule to calculate it. What changes? The n keeps changing. The input number changes. Okay. We give that input number a variable. Instead of saying input number, we just say n. Okay, so that's all the n is your input number. And your output number is the odd number or another variable. We just give it, it's shorter, it's quicker. Okay. But in our patterns, you guys have done many patterns since grade 6 and grade 7 and even grade 5 and grade 4. We know that to make a pattern, you times by the same number each time. And that is called a constant. If something doesn't change, it's called a constant. Okay, right. We're going to end there for today, guys. I did have some other things, but we can talk about it on Tuesday next week. All right, any questions before I hand over to Alzon?
No questions, ma'am.
Okay. Okay, Alzon, over to you.
Awesome. Well, I just want to say thank you again, Marlies, for this amazing session. I definitely learned a lot. I don't know about you guys. How are you feeling?
We feel fine.
Do you feel fine?
Good, man.
Well, that's great to hear. So I want to share with you guys something again. Do you think the lesson is over here? Do you think it stopped here?
No, ma'am.
It doesn't. Njabulo, what happens after this?
Ma'am, we continue with more lessons, ma'am.
We continue with more lessons. That is correct. But before we continue with those lessons, there's something else that needs to happen as well. Who can tell me what is that? Revision.
Homework.
Yes. So let me just, can you guys see my screen?
Yes,
I
ma'am.
just see a lot of faces. Can you see your faces as well?
Yes, ma'am.
Yes, ma'am.
Should we leave your faces? Let's let's put this there. And then I want to congratulate you because you just finished your second lesson of algebraic expressions. So well done, guys. There's only 2 more lessons left. I'm happy that you guys are here, but there's only 2 more lessons left. So next week, Tuesday, the 3rd of August, we'll have algebraic language. Or is it variables? Marlies?
Yeah, so it will just be a continuation of today.
Okay.
And yeah, so more in algebraic, just use writing number sentences and using variables like we did today.
Awesome. Yes.
Ma'am, algebra language, is it gonna be more like the letters than the numbers?
So algebraic language consists of letters and numbers combined. So what we did today, what we started doing is already a bit of algebra. Yeah.
Okay.
Awesome. Thank you for asking questions, guys. I think you all participated so
We
nicely
love
tonight.
questions.
Yes. Yes, you must challenge us with those questions. If Marlies
Yeah.
can't answer, I'll try. No, I'm just joking. I won't be able to answer anything. So like we spoke about now, revision. Where can you get your homework for Watobi? You can go onto the Watobi app and then type in algebraic expressions, or you can go to the topic algebraic expressions. Then after that, you can see algebraic language, and then underneath you can go to write basic algebraic expressions. Okay, do you all have that?
Yes, ma'am.
Awesome.
ma'am.
And tell me, can you remember what I said on Tuesday? What's going to happen to those who does the most homework? Does anyone know? Can anyone
Goes on the
remember?
leaderboard.
Leaderboard,
Yay!
yes.
So I
Leaderboard.
thought I will show you a sneak peek of what the leaderboard will look like. Are you ready? Can I show it?
Yes, ma'am.
So this
Oh,
will be the leaderboard.
just
Okay.
waiting for names to be written in the leaderboard.
At least I wonder whose names are going to be on here.
On Tuesday.
Man, you never know.
We never know. We'll have to wait and see. So this is where your name will be. And right next to it, we'll see how many lessons you've been doing throughout this week and before our next lesson. Okay. Okay, guys. So that's all from me. Thank you so much all for attending. It was so nice to see your faces. I hope you learned something tonight. And we hope to see you all again on Tuesday.
Yes, ma'am.
Thank you for the lesson, ma'am.
Thank you, guys. Keep well.
Thank you for the lesson, ma'am.
Thank
Bye, ma'am.
you.
You're welcome,
Bye, ma'am.
Bye,
Have
ma'am.
a good weekend. Bye.
Good weekend.
Bye,
Bye, ma'am. Bye, ma'am.
Bye.
Bye.